Hello, everyone. Welcome to my class. In today's class, we will start Module 2, Exploring Computerized Adaptive Testing. And I divided this class into several sections. The first section is what is computerized adaptive testing? So everyone here has taken so many exams, but most of them we call linear tests. Linear means the sequence of the question order is fixed, such as paper pencil test. Well, CAT is a new form of assessment in which tests are administered through a computer and adapt to candidates' ability level. So we should have algorithms. That algorithm will select items sequentially based on the student's performance. So this is a sequential test. Such experiment is just like you ask a student to answer one question. Based on the answer, you select the second question. They select items sequentially based on students' performance. Well, if students' answer is correctly, the next item should be more difficult. Otherwise, the next item should be easy, right? In that way, students will be more engaged throughout the course of the testing. CAT, there are so many advantages. CAT allows for immediate feedback because, we have algorithm. That algorithm will know immediately what is correct, what is wrong, and it can calculate the score. Will reduce test anxiety because, you can make tests shorter because the test is more efficient. And also, we can enhance security, test security, because from students, their items could be different. There are so many things about computerized adaptive testing. The next question is, which tests can be made into computerized adaptive testing? There are so many. The first is achievement test. Achievement tests, such as your classroom assessment. After class, you take exam, our test, how you did in the class, right? Or at many schools, there will be like end of year state assessment to students' progress. And we also have aptitude test, we have intelligence test, we have personality test, and we have diagnostic for mental disorder, blah, 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 so many. Remember, each time when you visit your doctor office, before your doctor seeing you, the nurse will ask you to fill many, many forms. And these many, many forms, they will answer many, many questions. And sometimes, there are so many questions can be, redundant. If we can administer this in computerized adaptive testing, so we can make such experience much more friendly. Also, the doctor can get much better information, right? So the future is unlimited about application. Well, let's discuss about current application. So this is not about future. We have already had so many exams of computerized adaptive testing. Well, everyone knows GRE, GMAT, Graduate Management Admission Test. These tests are already being in computerized adaptive testing format. We have all kinds of national council licensure exams, like a nurse license, teacher's license, all kinds of professionals licensure exams. And we also have military enlist exam called Armed Service Vocational Aptitude Battery Test, ASVAB. And these tests are large-scale application of computerized adaptive testing. Well, let's have a more specific discussion about how can we measure students' mathematical ability theta. Why we call it theta? Because it is a variable, it is unobservable. Unlike other measure, you can observe this true value. Students' ability is called a latent variable. And the way we can measure it is through exam by asking many, many mathematical questions. Well, according to Fred law, An examinee is measured most effectively when test items are neither too difficult nor too easy. So in order to develop an algorithm, we need to have models, measurement model, testing model, and we need to have item bank, and then we can tailor the items to the student's performance, something like proficiency. And here I give you very simple example. And these examples, we have two examinees, A and B. Examinee A, and her ability is 1.0. And we assume math ability follows normal distribution centered at 0 with 1 standard deviation. Let's assume this. And the other examinee B, his ability is lower, is negative 1.0. Okay, then the two examinees will be tested at the same time through CAT. You see, look at the examinee A. First item, she answered correctly, so we increase difficulty level. The next item, she answered incorrectly, then we decrease the difficulty level. And then answer correctly, we increase the level. Each time answer correctly, we increase the difficulty level. By doing so, you see on and on and on, you see the difference between two adjacent items' difficulty level will become smaller and smaller. So eventually, these difficulty levels will remain almost unchanged. That means the student has been measured very precisely. There's no need to admit small items. By looking at examinee B, you can explain this. And also, again, this horizontal, we just make horizontal as the sequence of item number. First item, second item, third item, 50th item. And vertical will be ability estimate. And we assume the distribution is normal 0, 1. And we also assume the difficulty item parameters. When you describe the item difficulty, and we can use a parameter in the model, and ability scale and item difficulty scale on the same scale, so that we can do this easily. So this is what we will learn from this class.